Okay, so I think there's gonna be 3 parts to this video. Wait, wow, there it goes. All right, so we've got angle 1 is congruent to angle 8. So if we can get back to the postulate, then we're set. So we need to prove that there's 2 congruent corresponding angles. So we're talking about 1 and 8. Let's go with this. That angle 1 is congruent to angle 6. Because vertical angles are congruent. Okay. And then now we've got that angle 6 is congruent to angle 8 by the transitive property. All right, now 6 and 8 are corresponding angles, so we can go straight to the fact that K is parallel to L now. Because congruent corresponding angles imply parallel lines cut by a transversal. And yes, we could write it all out like up here, but as many times as we're going to write this, if we can save a tiny bit of time by shortening it down with the implies arrow, let's do it. Okay. All right, so there's one theorem. So if you never have to prove it again. If you can show congruent alternate interior angles, then you're going to know the lines are parallel. Okay. So the next theorem, if 2 lines are cut by transversal and alternate exterior angles are congruent, then the lines are parallel. So this one I just picked a pair of alternate exteriors. So that's our given. And again, we're trying to get back to these lines being parallel. So again, I like to go through the corresponding angles. The corresponding angles just make sense to me. So I'm going to say that angle 3 is congruent to angle 8. Because vertical angles are congruent. And then I know that 6 and 8 are congruent by the transitive property from steps 1 and 2. Which leads me to K being parallel to L, because I have congruent corresponding angles, leads us to know that it's parallel lines cut by transversal. Okay, all right, next theorem. If 2 lines are cut by transversal and same side interior angles are supplementary. So 1 and 4. So we're going to say we pick 2 same side interiors. We're going to say they're supplementary. Let's prove the lines are parallel. So let's get it to here. If I know they're supplementary, I know their measures add up to 180 degrees. Which is the definition of supplementary angles. Okay. Let's see, what are we going to do now? Actually, did I even have to say that? That may be an extra step I don't need. I think I'm going to get rid of that. Hang on. Hold the phone. Don't write anything down for a second. Let me think through this, and then we'll come back. I think I can get away with not saying that, because what I could do is say that the measure of angle 1 plus the measure of angle 2 is 180 degrees, because that's a linear pair postulate. Now, I could have kept going the way I was going, but I think it would have been a lot more steps. I don't know if it would have been a lot more, but it would have been more. And I'm going to use one of those theorems that maybe we don't do as much as we should. So that makes angle 1 supplementary to angle 2, because that's the definition of supplementary angles. All right, and then let's look at this. Oh, I didn't even put angle 1. I just kept on going. Angle 1 supplementary to angle 2. So if angle 1 is supplementary to angle 4, angle 1 is also supplementary to angle 2, then we know that angle 4 is congruent to angle 2 because supplements of the same angle a little too close, are congruent. So that way we could use that theorem instead of having to go through all the adding up to 180 stuff, which we could have. This will just get us there quicker. And so now we know that angle 2 is congruent to angle 4, and those are corresponding angles, which leads us to K being parallel to L, because congruent corresponding angles implies parallel lines cut by a transversal. Okay. Actually, we may get done before she gets here. I don't know. How many more pages of this are there? One. Oh, no, I don't think so. Maybe she's late, though. We'll see. We're going to go as far as we can until we get interrupted. All right, so here's another theorem. In a plane, two lines perpendicular to the same line are parallel. And you have to throw in the words in a plane, because if both these lines aren't in the same plane, they can still be perpendicular to each other, but they won't be parallel to the same line. So stop for a second and picture that if they're not in the same plane, just to make sure you see why it's so important to be in the same plane. It's hard for me to explain that on a video, because what I would have done in real life is actually like taken two sticks and said, these are lines, and put them in different planes and have them be perpendicular to each other, and they are nowhere even close to parallel to the same line. But so here's where we're getting. So in a plane, two lines perpendicular to the same line. So we've got to show, well, we don't have to show it. Our diagram shows it. So T is perpendicular to N, and T is also perpendicular to L. Okay, so that's what was given. So we took this in the diagram and put it all into the given. So we know right now the angle 2 and angle 6 are right angles, because that's the definition of perpendicular lines. That did not look like perpendicular. Okay, so they form those right angles. And then we can say that angle 2 is congruent to angle 6, because we have a theorem that says all right angles are congruent. And then angle 2 and angle 6 are corresponding angles. So that means that L is parallel to N, because congruent corresponding angles implies that parallel lines are cut by a transversal. So I don't remember if I said this when Coach Black came up a few minutes ago. There's basically 5 parts to every proof, Ethan. So you're going to have the diagram. That has to be in every proof. And you don't wait, like you were talking about yesterday, wait until the end to put it in. You put it in at the beginning. Like the diagram is essential to everything else that happens. There's a given and a proof. So you state what you know. You state what you're going to find out. And then you have your statements and your reasons. So, like, that made me nervous when I walked by and you were leaving the diagrams out. Because the diagrams, to me, are what tell you what to do in the proof. And maybe that's just me, but I think it's the most essential part of a proof. All right, now, even though these are theorems, the proof of it is real. It's hard to put the proof of these into a statements and reasons column. So we're just going to show what this is, and I think you're going to be all right. So through a point outside a line, so you're given is you have a point that's not on the line. There's exactly one line parallel to the given line. And this is like say this is point A, and this is line L or something. We're trying to prove that this line right here is the only line parallel to that given line. So remember, by definition, parallel lines are in the same plane. So there's a reason why these notes look the way they do. Even though it is a theorem, it feels more like a postulate to me. Like, I don't know how you're supposed to prove that. That's just true. Like there is only one way you can draw that line in that same plane and be parallel to it. So I guess I kind of just ignored my what I told you about. We have to prove all the theorems, but I think you should just memorize that one because I don't know how you put that in statements and reasons without it just being overkill. And same kind of thing here. Like I don't think this is worth actually making a statements and reasons column. So you've got line L. There's a point outside a line. Let's do the same thing. Point A is up here. There's exactly one line perpendicular to that given line. So let's see. Here's L. Here's A. Those are in like those. That line and that point are just in the single plane because you can find 3 non-collinear points. There is only going to be one line. Let's say it's line N on this one that's perpendicular. So those two theorems, yeah, just memorize those and use them. So you'll like these kind of problems. This is called, I'm going to introduce you to something known as an auxiliary line. So auxiliary lines in math, you can put them wherever. Why do I have 2 black pencils up here? That seems silly. Okay, sorry. You can put them anywhere you want, and they can do anything you want them to do if they're helpful. So here's how I would work this problem. I would introduce an auxiliary line through point Y that's parallel to those other 2 lines. And then, to me, it helps to extend these. You may not need to. So it's like, oh, let's extend this out a little bit too. So if I'm looking at this line and this line, there's my transversal. Then this is 40 degrees, which means this is 40 degrees, which means this is 140 degrees, which means this is 140 degrees. Okay? And let's see what else we want to do. Oh, this line extended out, and you can either look at it as a linear pair or you form vertical angles. So this is 40 degrees. Let's say I take those off, and then I look at this set of parallel lines with this transversal. Then if this is 80 degrees, so is this. You got your alternate interiors off those parallel lines. And then you got 40 degrees there. 80 and 40 is 120. That leaves 60 degrees right here. All right, let's take off all the highlighted parts. Let's see what we've got. Find the measure of angle XYZ. So XYZ. So it's those two. Let's mark that up. A different notation. So it's 40 degrees added to that 80 degrees. So the measure of angle XYZ is 120 degrees. And the auxiliary lines are possible because of these last 2 theorems. So, you can only introduce the one parallel line in that plane. So that lets us draw an auxiliary line. All right, another theorem. This one we can actually prove and have it make sense. 2 lines parallel to a third line are parallel to each other. Okay, so here's our diagram. So 2 lines parallel to the third line. So they're saying L is parallel to N, and K is also parallel to N. So this is the line they're both parallel to. And yes, I know it's pretty obvious. You're like, well, duh, they have to be. But let's go through it. So we've got our given. We can say that angle 1 is congruent to angle 5. And that angle 5 is congruent to angle 9. So we know this is congruent to this, but we also know this is congruent to that because these 2 are parallel with this transversal, and 1 and 5 are corresponding angles. We could do these 2 are parallel with that same transversal, and 5 and 9 are corresponding angles. So the reason for both those statements would be that parallel lines that are cut by a transversal imply congruent corresponding angles. Okay, all right, let's get rid of all this nonsense. Okay, so, oops, that doesn't look much like a 5, does it? All right, so if 1's congruent to 5 and 5's congruent to 9, then we know that angle 1 is congruent to angle 9 by the transitive property. And therefore, if 1 is congruent to 9, then that's a pair of corresponding angles off of these two lines cut by this transversal, which makes those two lines parallel. So L is parallel to K because congruent corresponding angles imply parallel lines cut by a transversal. Okay? All right. And then, who knows? What time is it? 7? Oh, I doubt she may have forgotten to come. If she forgets, we're going to get done. All right. What two lines, if any, are parallel if the given information is true? All right, so if we know that the measure of angle 1 is equal to the measure of angle 4, well, those measures being the same makes those angles congruent. So you're always looking for two lines in a transversal to create those angles. So if those are congruent corresponding angles, that means line L has to be parallel to line T. All right, so what I would do if I were you, I would stop the video and try all these, and then turn the video back on and just make sure that you have the right answers. And remember, Ethan, do not assume that you get them right. You get yourself in trouble when you start assuming stuff. Make sure, okay? All right, so you're stopping it. I'm going to keep going. You're going to turn me back on. So angle 6's measure is the same as angle 4's. So it's basically, can I create those two angles using two lines and a transversal? I sure can. Using those two lines in a transversal, 6 and 4 are alternate interiors. If alternate interiors are congruent, then the lines are parallel. So what is that, a J? Is that a J? I think it's a J. It looks weird. So J is parallel to K. Okay, all right, next up. The measure of angle 2 plus the measure of angle 3 is the same as the measure of angle, what am I saying? Okay, so 2 and 3 put together, that measure is the same as this. I don't know why I was separating them out. So the measure of angle 2, sorry, I skipped down to number 4. So if 2 and 3 put together are the same as 5, that's going to make those angles congruent. That's going to make, if I create those big angles, it's because I use that line, those two lines, and this transversal. So yeah, that's going to make lines L and T parallel. Okay. All right, next up, let's see. I'm supposed to know that the measure of angle 2, 3, and 8 add up to 180 degrees. Okay, so 2 and 3, I can put those together. 8 is right there. Okay, so if I look at these two lines and this transversal, those are same side interiors. These two put together make one angle. So the measure of that angle plus the measure of angle 8 makes 180 degrees. That makes those supplementary, which makes us have same side interiors that are supplementary, which makes lines J and K parallel. Okay. All right, next up, 6 and 8. Let's see where 6 and 8 are. So 6 right there, 8 right there. I could use this line, this transversal. Those are corresponding angles. We just said they're congruent. That's definitely going to make lines L and T parallel. Okay, all right, what's next? 7 and 1. Okay, 7 and 1 are just vertical angles. That has nothing to do with parallel lines. Like 7 and 1 are going to be congruent all the time. So, yeah, that doesn't prove any kind of parallel lines. Okay, angle 1, angle 8, all 75 degrees. Okay, so angle 1 and angle 8 are the same size. They're both 75 degrees. Those are created by, these two lines and this transversal. Those are alternate interiors that are congruent. That makes lines J and K parallel. Okay. All right, what's next? 5 supplement 6. Okay, so here's 5. Here's 6. Those are created by these two lines and this transversal. Those are same side interiors. If they're supplementary, we have same side interiors that are supplementary, then we know we have parallel lines. So J is parallel to K, knowing that. I'm going to get done. Okay, 4 supplements 5. Let's see where they are. 4 supplements 5. Well, that's just a linear pair postulate. That has nothing to do with lines being parallel. We don't need 2 lines in transversal to create those 2 angles. And then, okay, 2 complements 3. So 2 and 3 are complementary, which means it's a right angle. And 5 is 90 degrees. So that means that's a right angle, which those are both 90. That means they're congruent. They're corresponding angles. This line, this transversal. So that means that L is parallel to T. And then you're going to do these problems out of the book. I've got the answers are going to be attached to your notes as long as I remember to print them out during my planning period. And I think we're good now. I think this is kind of fun. It's much easier for me because I can erase on here. But like I said, anytime we have a test or a quiz, I will give you as many copies of that picture as you might want to use. And then you can get highlighters because I just think that makes it a lot easier to see. You may not need it, but even if I don't need it, I still want it because it just pops. I can see exactly what's going on. Okay.